Hello students, welcome back. Let us resume our discussion in section 4. Please stop the playback and read through. So what do we have here? A water tank has the shape of an inverted circular cone with base radius 2 meters and height 4 meters. Water is being pumped into water at the rate of 2 cubic meters per minute. Find the rate at which the water level is rising when the water is 3 meters deep. And actually the problem came with this picture. So inverted circular cone like this, and then as more water is being pumped in, H will increase, water level will rise, and the volume of the water will also rise, and that's going to increase at this rate. The volume of water that is being pumped in. So you see, water is being pumped in at the rates. The problem did not specify volume, but you should be able to see that this 3 cubic meters is a unit of volume, and then this rate is the rate of change or rate of increase of volume. So you should get this. Okay, we got one. Find the rate at which, okay, we're going to find this rate. But what is this rate? The water level is rising when the water is 3 meters deep. So this 3 meters water level, that's the other quantity. H is 3 right now. Well, that's the structure. H is 3 right now. And H prime, that's what we want to find out. Agreed? The problem did not specify the volume. It simply said water is being pumped in, but from this unit and from other wording, you should be able to see that it's V prime we are talking about, the rate of change of volume. And the rate at which the water level is rising, this one is straightforward. H prime, that's the quantity we want, and H is 3 meters deep. Okay, so far so good. If we have a relation between V and H, and then take the derivative implicitly so that we have VH, V prime and H prime, and then two of them are given, we are going to get equations, systems of 2 equations and 2 unknown variables. We can do it, but, big but, big but. What's the relationship between V and H? From this picture, can you think of that? Volume of the cone is 1/3 pi r squared times h. Remember the volume formula of the cone. Yes, this is inverted, so we call this one as depth instead of height. Still, it's the same idea. So, we have 3 variables here. V, h, but also r. We have a problem. If you take the derivative implicitly here, I'm going to end up with 6 unknown variables, V, R, and H, and also V prime, R prime, and H prime. So how do I reduce this? There got to be another relation somewhere so that we can reduce this. Where is the second? The water tank has the shape of an inverted circular cone with a radius of 2 meters, the top, and 4 meters total, and then in general radius r and h. From this, can you figure out the relation between r and h? Well, if you pay attention to these dotted lines, you're looking at a right triangle, two right triangles rather, sharing the same vertex. So we have a similar triangle, and then the ratio R current versus total R to H should be H current depth versus the total depth H to 4. So we're going to get this. R to 2 equals H to 4. This proportion. Or R over 2 is H over 4. You see? This is pretty picture. So, and as a matter of fact, thanks to this dotted lines, you can see that 2D structure, but many times 3D pictures are just too pretty and gives you too much information that you cannot really see what is going on. So I drew another picture here in my solution key. Okay, let me copy and paste that here. You see, if you look at the same picture here sideways, you're going to get really a pair of triangles like this. And then R changes with H. And then total 2 meters, 4 meters. So R to 2 is H to 4. That's the relation. So you see R, highlighted in brown, to 2 is H to 4. So from here, I can solve for one variable and plug it in, and then you're going to get a relation of 2 variables only. Now, which one shall I eliminate? Which one shall I eliminate? I should eliminate R. The reason is, look at the original problem here. The original problem, this reading here gave me V prime and H, and looking for H prime. Doesn't say anything about R. We need the relation between V and H. That's why it makes sense to remove R. So let's remove R from here. R is, flip it over, so 2/4 H, and of course nobody writes like this, 2/4 is 1/2. So R here is 1/2 H, and if you plug that in right here, then finally you're going to get the relation between V and H only. V equals 1/3 pi 1/2 H squared times H. And this reduction, they come from this geometry here. So we actually have to deal with 2 relations here. First relation, 3D relation, V, R, and H. And second relation, that's 2D relation, R and H only. So from the second relation, we can eliminate R, solve for R, and plug it into the original, and then we got a relation between V and H only. One more step, a bit too complicated, so let me simplify into this form. 1/3 pi, and then let's see, 1/2 squared, so 1/4. 4 times 3 is 1/12. And then H cubed. That's the relation. And here is equation number 1. Now I don't need this picture anymore. We have the equation number 1. And then 2 values given. Now if you get equation number 2 from the implicit differentiation, we're all set. Are you with me here? V prime equals to, take the derivative, 3 comes out as coefficient, pi H squared times H prime. 3/12, that's the same as 1/4. So after all the geometry, we've got into this equation. V is 1/12 pi h cubed. So they're related like this. V and h are related like this. And the rates, V prime and h prime are related this way. 1/4 pi h squared h. And then this is h. So keep it with green. Color coding really help. Yeah, to see the color coding better, let me take a little bit bigger font. This one doesn't have to go that big. Oh, that's too small. Let's go back there. Okay, all right. Let's copy and paste and let's plug in numbers. H is 3, so that's 3. V prime is 2, and h is 3. And the h prime, okay, that's the quantity we are looking for. Agreed? Okay, let's do our computation. Well, the problem did not ask you about V, but I could have asked you. What is the volume of the water at this moment? How much water does this water tank has right now? I could have asked you, so let's solve that. So plug in here, 3 to the third power is 27 divided by 12, 9/4. And then you can punch in the calculator and get decimal expression if you want to. Now how about this one? H prime, I have to remove everything here. So this equals to what? 2 was there, and then denominator here multiply, so we get 8, and then divided by pi, and 3 squared is 9, so 9 pi. And then if you calculate this, what do you get? Oops. Okay, luckily I got it back. Oh, that's what I'm getting. And this problem did not specify how many decimal digits to take, so from here, do whatever you want to do. How about the volume, by the way? This problem did not ask you about volume, but I could calculate, so let's go ahead and do that. Alright, that's what I'm getting, 7.8 something. Okay, I guess that completes the problem. So water is being pumped in, and then from there we have the volume formula, volume of the cone, and then from here V prime is 2, H is 3, we want to find out H prime. Looks good, but not yet. We have too many variables. We have to reduce it. Let's look for another relation. That relation is the triangle here, right triangle, or yeah, as you see here. From there, you can find out the relation between R and H. So for R, plug it in so that we end up with a relation between V and H only. Finally, we are in business. Take the derivative implicitly and then plug in numbers. Plug in numbers, we can solve this system. You can open up my answer key here, but that's going to be pretty similar. So I'll end here.